Hello students, today we are going to see relativity of time. Another name for relativity of time is time dilation. Time क्या होता है? Dilute होता है, dilation. So let us see. हमने as usual दो frames consider किए हैं, S and S dash frame. Initially दोनों coincide करें. After some times one frame S dash frame is moving with velocity v along the x direction, and this is origin. This is at t is equal to t dash is equal to 0. Both O and O dash, they are coinciding. This is z axis, this is y axis. Let S and S dash be the two rectangular inertial frames of reference with their axes OX and O dash X dash are collinear. Let V be uniform velocity of the frame S dash relative to the frame S in positive x direction. Suppose two events, हम उसके लिए बोलते हैं, let us say that there are two signals. Says two signals occur at a certain point. Now we will consider, let that point be P and its coordinate are x, 0, 0. Means for the x coordinate some point, but for y and z it is 0. In the frame S at time t1 and t2. If you are standing on the stationary frame, then two signals which appear at time t1 and at the second signal appear at you heard at t2. The time interval between these two events is measured by a clock. At rest at that point in the frame S. This time interval is called the proper time interval, and we will denote it by T0. Therefore, proper time interval T0 is difference of the time. This is our equation 1. Suppose for an observer in the frame S dash, the events occur at times t1 dash and t2 dash. This is with respect to an observer who is sitting in frame S dash, which is moving with velocity v. Hence, time interval t measured in the frame S dash is given by t is equal to t2 dash minus t1 dash. This is equation number 2. The proper time interval in the frame S in which the events occur at the same point is measured by means of one clock, but the times t1 dash and t2 dash are measured by means of two synchronized, very important, we are making use of two synchronized clock to measure the two times, that is t1 dash and t2 dash. By means of two synchronized clocks in the frame S dash. We already know the Lorentz transformation, so now we will make use of Lorentz transformation equations. Now, according to Lorentz transformation equation, we have t1 dash is equal to t1 minus vx upon c square upon under root 1 minus v square upon c square, and t2 dash is equal to t2 minus vx upon c square upon under root 1 minus v square upon c square. Now t2 dash minus t1 dash is equal to t2 minus vx upon c square minus t1 minus vx upon c square upon under root 1 minus v square upon c square, t2 minus vx upon c square minus t1 plus vx upon c square upon under root 1 minus v square upon c square. We will cancel out t2 minus t1 upon under root 1 minus v square upon c square. Let us denote t2 minus t1 dash by t. T is equal to this t2 minus t1 by t naught upon under root 1 minus v square upon c square. This equation 3 is called Einstein's time dilation equation. This is Einstein's time dilation equation. Now, the quantity under root 1 minus v square upon c square is always less than 1. 1 minus something means it is always less, and that too under root. So it is always less than 1 for a moving object Hence, t is always greater than t0. Therefore, t is greater than t0. That you need to remember. So this is famous Einstein's time dilation equation. Now let us interpret this time dilation equation. Interpretation of time dilation equation. Thus, it is clear that the proper time is least. Proper time interval, we will write as interval, int. Interval is the least from this equation. T is greater than t0. So t0 is least, and the time interval measured in a frame which moves relative to the frame in which the events occur is longer than the proper time interval. This effect is called as time dilation. Dilate means become larger. So this effect dilation. Now let me tell you one example. Now we will consider two clocks, one on Earth and one on the spacecraft. The moving clock in the spacecraft will appear to tick with at a very slower rate than at the stationary, than when we compare with the clock on the ground, as observed by the observer who is also standing on the ground. So this is the best example, time dilation. The moving clock in the spacecraft appear to tick. It is a sound. Tick means the sound of the clock, tick, at a slower rate than the clock which is stationary one on the ground, as seen by the observer on the ground. So the clock which is on the spacecraft will move with a slower rate compared to the clock which is on the ground. This is the interpretation of time dilation.